So now we're going to be graphing from standard form, and we're going to dig more into what different parts can we see on the equation that are evident in the graph. And we really need to be focusing on making those connections so that it's easier for us to find patterns and hopefully be able to graph easier and faster than having to create a table every single time. So in the first video, I mentioned C. And C is a lot like in vertex form, it's that K value, kind of. I mean, it's more like it's our Y value of the vertex. This is our Y-intercept of the graph, okay? So I guess we could say it's actually more like slope-intercept form, and it would be more like B, out here at the very end. And we're seeing this pattern, we should be, right? That this constant that's at the end of our functions usually has something to do with the Y value of some sort, either the Y value in the vertex or it's the Y-intercept, okay? So let's look at this one. Let's plug in some values here. So let's say we have 2x squared plus 4x plus 3. And we want to graph this. The first thing we want to do that's helpful when graphing our parabolas is we want to find the vertex. So there's a formula that's going to be helpful, and it's basically, right, let's think about this. We need to find, the first value would be x, right? So that's our h value in vertex form. So the h is the same as finding the x value. And the way that we do that is we use this formula that is negative b, or opposite of the b value, divided by 2 times a. So let's just do that. Let's practice. Opposite of 4 is negative 4, and 2 times 2 is 4. So what do we get for the x value in the vertex? We get negative 1. Now we need to find the y value. We know that once we have a value for one of the variables in a point in an ordered pair, we just substitute it in and solve for the other one. So we're going to use this negative 1, and we're going to plug it in to our function here. So 2 times negative 1 squared plus 4 times negative 1 plus 3. Let's evaluate it. We get 2 times 1, when this is squared, that's 2, minus 4 plus 3, that gives us positive 1. So our y value in the vertex is positive 1. Now we can come over to our graph and get our vertex done. Negative 1, positive 1, right there. We need at least 2 more points, and then we can use those to reflect across our axis of symmetry. All our axis of symmetry is our x value in our vertex. If our parabola is opening up, and we can see that it is because there's a positive 2 for our a value, I know that my axis of symmetry, I can sketch it out here, is going to go up at negative 1. Now to find other values, all we need to do is pick a value for x, plug it in, and solve for y. So I'm looking here. Maybe I want to go 1 to the left. I'm going to try negative 2 for my x value. So 2 times negative 2 squared plus 4 times negative 2 plus 3. 4 times 2 is 8. 4 times 2 is negative 8. And this gives me a value of 3. So when x is 2, or negative 2, whoops, y is 3. So I can put that point here, negative 2, positive 3. Now, I see that this point is 1 unit away from my axis of symmetry, so I go reflect it on the other side, and I'm right here on the y-axis. Let's do another one. maybe I want to go one more to the left. So I'm going to try -3 for x. Evaluate this. 9 times 2 is 18. Minus 12 is 6 plus 3 gives me 9. When x is -3, y is 9. So I can put that point on the graph. And it's going to be right about here. Now I reflect it. That is 2 units away from the axis of symmetry. So I go 2 on this side, follow it up, right here. Now we connect them. And we are not doing this. Okay, I saw that we're not doing that. It is not an absolute value function. It curves. So we just do our best to curve it through the points, making a U shape, not a V shape. And that is how we graph from standard form. Notice also that I said in the beginning, C is our y-intercept. We should be able to see that. If we look, 1, 2, 3, that's where it's crossing the y-axis. So the point 0, 3 should exist in your graph, in your function, and you should be able to see it at your y-intercept. The next thing we're going to do is we're going to convert from vertex form to standard form, and I'll show you how to do that. So let's take this equation . Now what we learned in the last unit about factoring and multiplying polynomials is going to come in handy here. This is why we did that first. We realized that we need to write this out when we multiply it. That's our first step. So our first step is going to be to expand our perfect square here, our polynomial, so our binomial squared. Expand the binomial squared. So we can bring everything down and then we rewrite this. And maybe off to the side you want to do this math here. So I'm going to just do this up here. And I'm going to FOIL it, right? Multiply. Hopefully you've seen the pattern, and if not, you can tell that this -1 is going to multiply times this x twice. So you're going to have -2x. But we can keep going there. We can just factor it out, or multiply it out. And we can see that there's where the -2x comes from. So what we have when we expand and multiply is x squared minus 2x plus 1. Bring down the positive 48. Now this is not in standard form, so you got to realize this is not the y-intercept yet, okay? We have to convert it to standard form, then whatever that c value is will give us the y-intercept, because right now this is a k, this is vertex form. So this is where the vertex should be, at 1 and 48, okay? All right, so we have expanded. The next step is that we are going to distribute this 16, again, using our multiplication property with polynomials. This was the leading coefficient, or the a value, so I'm going to say distribute the a value, okay, which is this. So here we go. So we get -16 x squared plus 32x minus 16 plus 48. Bring that down. Now combine like terms. So step 3, combine like terms. Whoops, wrong one. Okay, so you see that these are the only two that can go together. Everything else stays the same. So this is what we get. And now we've converted this to standard form. Now, relating back, think about this. This is where the function, the graph, should cross the y-axis. So this is the y-intercept. If we take b and divide it by a, we would get -2, which means that one of the x-intercepts of this parabola is going to be a +2. Remember in the first video that the ratio of b to a was equivalent to an opposite x-intercept of one of the x-intercepts, okay? So all of these things we need to become fluid with moving from vertex to standard, realizing what the different forms give us. Vertex form is nice. It gives us the vertex, and then we can substitute in values and graph from there. Standard form gives us the y-intercept. We can reflect that, but we need the vertex first because we need the axis of symmetry. And we can use that formula -b over 2a to find our h, our axis of symmetry, our x value, all the same thing, and then substitute, find the y, and get more points. So multiple steps here, but it's all connected. So now you're going to take some time to make sure you've taken really good notes first, and then use them as you work on the next activities.